Hey, welcome everybody. Thank you for joining us today at Cold Jet's Dry Ice Blasting 101. I'm Mike Henderson. I am your host. Let's get started. So, first, a little bit about me. Um, that's a picture of me in March of 1994. I had hair and looks and everything. I was hired here to do some marketing work. I did trade shows and I bought advertising and I did direct mail and basically lead generation and obviously industrial fashion modeling, um, stuff like that. I did that for a year, and then afterwards, Cold Jet moved me to Lake Geneva, Wisconsin, where I took over a 15 state territory. I did that for several years, and then I moved to St. Paul, Minnesota, where I started working with 3M in the mining industry. And in 2001, I moved back here to Loveland and I took over the Southeast, which was Kentucky to Florida and the Caribbean islands. I that I did that territory got smaller, and after 30 years, we all decided that 30 years on the road was enough. And I now, in my current role, do this webinars, public speaking, and one thing I do and I love to do is answer the phone. The phone rings here. People have ideas, and will this work for this? And can you use this for that? And I field those calls, and I really love that part of the job. Okay, let's get started. So this is our global headquarters in Loveland, Ohio. If you don't know where that is, we're right outside of Cincinnati. Out of the hundreds of people we employ around the globe, 150 are here. This is where our senior management lives, all of the administration. So, purchasing and engineering, and also the people that run our world-class manufacturing facility where we laser cut and weld and machine um, and we wire all of our own electrical panels and assemble everything. We also have a warehouse where we store parts, and we staff a whole team of service people to answer phone calls from around the globe on issues you may have. We also have bricks and mortar and staff in Belgium, Germany, China, Japan, Spain, Poland, Mexico, Denmark, Canada, and in the US on the West Coast, we have a place in Rancho Cucamonga, California, of all places. The way this all started was back in the 70s, the government was giving away all this federal research money for companies that wanted to find better ways to strip paint from commercial aircraft. The process to strip the paint off of 747 included a lot of chemicals and work and disposal and treatment of those chemicals. And so Lockheed Martin had gotten their fingers in that money, and they assembled a team and they came up with several processes, this being one of them. And also from that school came walnut hull blasting and cornstarch blasting, and they even tried popcorn and all these green technologies. But this one, they really wanted to work because it had zero secondary waste stream. And the only problem was it didn't work. Dry ice, we learned, does not strip very good paint. Aircraft paint is good paint. Nor in its infancy, we didn't really understand how to manipulate the pellet to get it to gentle up, because at the time we were throwing pellets at the skin and we're dinging up the aircraft. So this was just not going to work. So some people on that team knew some people in Cincinnati, Ohio that could build stuff, and they got some funding and built a cold jet. And back in those days, it was about the size of a UPS truck. It had to make ice and it had drive around on the back of a semi. It was a big deal. Um, when I came here, the super mini model was the size of a Volkswagen, and it weighed about 3,500 pounds. So we've come a long way. Uh, but what I wanted to say, the R&D dollars that have been spent on this technology by this company have brought us where we are. Without it, this would not be a product. This would not be an industry. This would not be technology that's used anyway. Since 1988, when we opened the company, we have installed 25,000 plus machines in some 58 or 60 countries. That map you're looking at right there is pretty accurate. We also build the world's best dry ice production equipment, and we have installed about 1,100 of these things in various parts of the world. Okay, so here's kind of our current lineup. Like I said, it's come a long way. We have entry-level machines like that ice rocket that you see all this is for the occasional user, or the hobbyist. You wouldn't believe the buildings I've walked in to see people's car collections, and they've, this is what they want to buy to clean their own equipment, and God bless them. The next in row is our Aero line. This is super heavy duty. This thing is all welded steel, 18 gauge stainless, foam filled pneumatic, flat free tires. It's got a great big motor in it, so it'll last you 10 years. It has multiple agitation, which is important. The hose, the applicator, everything has to be super heavy duty. And it's designed for the hardcore environment, steel mills, foundries, oil fields, contractors that have, gorillas that work for them that are hard on equipment. Next is the Ultra line, which is what we call a smart machine. This thing has inner working parts that manipulate the pellets to do different things to get different results. And then you can dial in recipes. By that, I mean you can preset the air pressure, the pounds per minute, the size of the particle, and program that so that the operator who needs to log in, that's the recipe he's going to use to do that particular application. That way it's not overdone or underdone. It also will collect data, meaning it will send the supervisor a note because it has IoT in it. Joe is running the machine right now. He's using exactly this much trigger time on this program, and he's using exactly this much ice. This is great for supervisory reasons, but also this is a report that you might not need to put into a file. If it's something critical, a medical or an aerospace type thing, you might need to put that in the file so to refer back to it later. It also has a diagnostic system in it. So if it's starting to run funny, or if it feels like it's pulling a funny amperage, it will send you a note, and then we can get online and see that, so we can fix it before it becomes catastrophic. And then we have these tabletop units, which are smart too. They gather data and they have IoT, and they're popular with people that mold stuff, because you can run it up and down a mold press row, and you can plug it into almost any airline, and just real simple to run around the plant with. We'll talk more about that later. What is dry ice? Dry ice is nothing new. It's been around 100 years. It's frozen liquid CO2. Dry ice is cold, as we all know. It's 109 degrees below zero. Dry ice sublimates, not often confused with evaporates. Sublimation is where it goes from a solid to a gas. And the great thing about that is it leaves behind zero water, residue, chemicals. It's literally safe for hundreds and hundreds of applications, especially the hard ones and critical ones like pharma and medical devices and nuclear and stuff like that. Dry ice is made from recycled CO2, so it's a byproduct. Okay, and this is how that works. So, um, when you distill grains to make ethanol or alcohol or ammonia, these are spirits, and they're all made in a great big moonshine still. So when you distill that, there's a solid runoff of pure CO2, and that'll be piped next door to another plant, and usually it's an industrial gas company like Airgas or Praxair or one of the gas, and they collect it and they scrub it and then they pressurize it. Now CO2 gas under pressure becomes LCO2 or liquid CO2. And that way it can be stored and transported and trucked to a facility where they're going to convert it into gas. Now, I'm going to read this statement, but the California Air Resources Board, which is the toughest governing uh, management that looks after CO2 emissions and greenhouse gases and things of that nature, states due to the fact that dry ice is recycled CO2, it will not contribute to your greenhouse gas score. In the calculation of carbon footprint, CO2 is accounted for at the producer level. So the ethanol plant pays for that carbon footprint. It is not counted a second time. So you need not worry about your carbon footprint upsetting what's going on. Okay, so here's how it happens. Um, this guy has received a silo of CO2 that's probably a 30 or 40 ton silo. Why does it have to be so big? It doesn't have to be, but it's convenient to have it that big so you can take an entire truckload. Um, if you start splitting up loads, it adds to the tonnage cost, and that's a whole. All right, so it's piped over to that cold jet machine. That is a cold jet pelletizer, and it is inside that pelletizer is a hydraulic pump, and there is a hydraulic ram and piston. Okay, and that's attached to a stainless steel barrel. And when we release or inject the LCO2 into that barrel and it experiences the atmospheric pressure change, it flashes into a snow. And as it fills up, a snowstorm begins to go on there. And it's full, so that activates that ram and piston, and it packs that snow into a cake, and it shoves it through an extrusion die, or we call it a spaghetti die because it looks like pasta when it comes. And as it falls out into the box, it's brittle, so it breaks into shorter pieces, giving you a more uniform 3 millimeter pellet. So if you look there, it's falling into that blue box. Those boxes keep the dry ice for a week. Now you do lose 4% of the product a day to just to natural sublimation, but it will keep for a week. So you get a weekly delivery of dry ice, how many of our boxes you're going to use, and then the next week they pick up the empties and bring you new ice. It runs very smoothly. How do you get it? Okay, well, our sales staff can show you exactly where to go for your particular location, but it comes from an industrial gas house, Airgas, Praxair, one of these guys, or you can just call a welding supply house. They usually have it too. They have a lot of CO2 on site, so often not all of them, but a good deal of them make their own dry ice. And then there are companies that have just set up the equipment to make and deliver dry ice, and we call them independents. Um, those two guys are holding dry ice. So the guy on the left is holding 3 millimeter pellets. That's what we use for cleaning. And on the right, that looks to be about a 16 millimeter nugget. And this is what's used for its BTU value, meaning it's used to ship foods, medicine, biological stuff. It has a lot of applications, but if you're going to ship some food somewhere, probably it's going to show up like dry ice here in the States on a national average is 30 cents a pound to 80 cents a pound. Um, to do industrial cleaning, most operators run about 100 pounds an hour. Okay, so if you're getting it for 30 cents a pound, that's $30 an hour to operate. Here's how it works. Okay, there are three things that make it work. So we load the pellets into the machine. The machine is then hooked up to your compressed air system. All right. And the machine meters the pellets into a airstream and shoots them out of a gun and nozzle. Three things happen. There is kinetic energy when the pellet strikes the surface. Now, we talk about it being non-abrasive. Abrasion refers to when you abrade a metal surface. We do not abrade anything, okay? But there is some scrubbing action. Second, there is the thermal shock, and that is what happens when the contaminant, the dirt, whatever you're trying to clean, becomes cold faster than the substrate or the surface that it's stuck to. So it fractures and releases its bond. Okay. Then there's something called gas expansion. Now we've made that pellet and compressed it, and it has a certain hardness. When that strikes the surface and you force its sublimation, there's a bit of an explosion that happens, and it causes a lifting effect on the contaminant. Okay, so you have the impact of the pellet, the thermal shock, and the gas expansion. The best thing that happens is it all sublimates back to a gas. You don't even see the dry ice. The only time you see is when you're loading it into the machine. When it's coming out at 900 to 1,000 feet per second, all you see coming out is that vapor path rate. So there's no ice or pellets exploding and bouncing all over and interrupting the workspace or bouncing onto the operator, making him unsafe. Frankly, this is the most popular job in the plant because it's nice and cool and is so the operator. Okay, there's something called the Mohs hardness scale. Okay, and this is where they measure the hardness of aggregate to measure it against a scratch test if they're going to test something. Okay, so on the Mohs hardness scale, talc is a number 1, diamond is a 10. Well, dry ice is about a 1.5. Your fingernail is about a 2.5. All right, so that tells you just how gentle it is. Um, so this guy right here, which found out earlier, that happens to be me, is cleaning a mold that makes a dashboard. Okay, so this mold is rather delicate. It's very expensive. That might be $1 million mold. And after you make so many parts, it gets fouled because there's an off gassing or a chemical that leaches out of the plastic after you make so many of them. And if you don't clean it, the part looks funny. It gets a funny gloss level on it. Well, the last thing you want to do is go in there with something difficult and hard because it's going to tear that mold up. And so now it needs a very expensive repair or maybe a replacement. And then like this one, you have all kinds of tricky geometries and things that you can't reach in. And it's just, to do this by hand is very tricky. Again, no water, no chemicals, no disassembly, and it's just a breeze for the operator to operate. So we to explain that we are very delicate, we tell people we can take the M off an M&M, and that's exactly what I'm doing right there. Now, is this a real thing? No, but we're proving a point. I'm cleaning that M off without, and of course I'm. All right. So yeah, I do that about 40 times a day. Okay. So, okay. Here's this thing. Those guys. All right. Okay. Dry ice is completely water free. In this particular case, this house had a water intrusion. And if you know anything about mold, what happens is you need water and you need something organic and a mold spore. And now you're growing mold. All right. What in this case, the contractor that they hired came in and power washed the mold off. Okay. Well, it looked great when he left, but 2 days, 3 days later, they had the 3 times the mold. You can't fix a water problem with more water. Dry ice is completely dry and it takes all that mold off and leaves it dry. So there's not a chance of a respore. Secondly, it gets all in the nooks and crannies and between the board and joist. So it's more thorough. Because there's spores in between there, and if you leave it alone, you're gonna get a respore, and then the contractor has to come. So it's water free. Um, it's completely chemical and detergent free. So in this case, that guy's making granola. All right. So they put the oats out there, and then they cover it in molasses and sugar and flavoring and juice and sticky stuff, and now it's stuck on that conveyor. Now, to clean that off would takes thousands of gallons, and now the water ends up on the floor. It's got all that food in it, and they have to corral it and squeegee it, and it ends up going down the sewer. And okay, that clogs up the sewer. It ends up at the waste treatment plant, and that's a problem, and it's just very taxing. But let's not get away from the fact that look how clean that is. Um, that is amazing level of clean that they're achieving there with the effort they're doing, and they're using a recycled byproduct. No secondary waste stream. Okay, this is a prison in Ohio. This is where they filmed the Shawshank Redemption. All right, and that is a cast iron staircase that has lead paint on it. Now the paint's coming off pretty easy because it's old. Um, but normally, if you went to um, clean that with a traditional blast media, let's say it was sand, just for safety, for sitting, because um, you would have piles and piles of sand that's now contaminated with. And what has to happen is that all gets loaded into a 55-gallon drum, and you put it on a truck, and it goes off to the landfill. All right, now can you imagine how much sand and contaminated sand you've got to put in the landfill to do the entire prison? If you use dry ice, the ratio of contaminated sand to just paint chips is like 50 barrels to one. And I don't know what it is now, but like 10 years ago, I checked on it, and it was like $2,000 a drum to put it in the landfill. If you start doing the math, this adds up very quickly. So it's no secondary waste stream. Reduction in downtime. So what this guy's doing is that is a big heat exchanger or a radiator that is cooling all of the equipment used to extract oil out of the ground. So they might be extracting oil, maybe it's natural gas, but they're mining. If that thing gets clogged up and it's outside and it's dirty and it does get clogged up, they have to shut the whole line down. All right. Now, this thing, they might be making $20,000 a minute, maybe more, maybe less. I don't know. But that's not the point. The point is, um, they've got to shut things down. And now that money stops. Secondly, that radiator right there could be $5,000 or $10,000. So they have to replace that thing, and they end up sitting out in the field. If you look at that right now, if you can see the dirt's coming right out of the back of that thing. So he's cleaning that thing while they're in production, out replacing that thing. And also, this again is a very pleasant job for the guy that's got to do it as the alternative to swapping it all out and replacing it. I love these because I'm a car guy. So, um, I've been detailing my cars with dry ice for years because I always had one. But when the rest of the world started to do it, I got excited. I mean, look at that greasy transmission there. All right. It would normally take a day to clean that. He probably did that in 5 minutes. And then there's that undercoating there. These classic car guys don't want that undercoating on there. It doesn't look good in the show when they're going to take it to a show or for resale. Um, to get that car sale ready or show ready, he might spend a month underneath there trying to do it by hand. Our way, maybe a day, maybe. Okay. And then we talk about ancillary applications. Most production company or most manufacturing plants buy this for some to solve some production problem. Okay. But almost always you have a little dry ice left over. So you go around and clean stuff. There's all kinds of stuff to clean. Materials handling equipment, fans. What's going on here is that's a dairy. And that milk has gotten all over the pallet racking and it's dried up, but it stinks and it's spoiled. And if they go get a steam cleaner or a power washer and power wash that off, it just reactivates it. And then it makes a huge watery mess with food and bacteria in it. This guy has got a forklift covered in dog food. All right. Now, if he is going to power wash that thing off, that dried dog food now starts to make its own gravy. Okay, and it gets all over the floor. You got to corral it. It ends up in the sewer. It stinks. But it's not only that. There's an individual that has to sit in that forklift and drive it all day. And the dog food gets all over the steering wheel, the seat, the controls that he uses to manipulate the rack, on the pedals. And then the forklift is driving all over the plant, delivering this bacteria. When the inspector shows up, they go right over that forklift and start to swab it. And because it's hard to clean, often it doesn't get done. This makes it easy to clean. I like this one because I'm one of those guys will make everybody sit in the dark and watch TV because I don't want to pay the electric bill. This motor is designed to self-cool itself. Okay, because you got those fins there, and behind that shroud right there there's a fan in there, and that fan is designed to pull air across those fins, and that's what keeps it cool. Well, people don't ever clean these things because they don't want to get them wet. All right. And if you remove that, they call it a bell, but if you remove that shroud underneath there and look at the fan blades, it doesn't look like fan blades. It looks like 3 chicken wings. It's not pulling any air across those fins. Now, what happens is that motor runs 3 to 5 amp higher than it should, at more than its design point. If you go into a plant and start counting motors, you might have 2,000 motors in there, maybe more. Um, and if you've got 2,000 motors and they're all dirty and they're all running 3 amp higher than they're supposed to, that could equate into $20,000 a month in electric bill that you don't really need to be paying. You can take your extra dry ice and just go around and clean these motors and these control panels. These are everywhere. They get dirty, they get gunked up, they cross conduct, they get hot. The poor guy that's got to PM this thing has got to wade through all the dirt before he can start to work on it. Because it's non-conductive, you can go through and clean all this stuff without any water, chemicals, or disassembly. It's beautiful. Okay, the overall equipment effectiveness. This is a score that is given to a piece of production equipment. Okay, it's measuring, is this thing running as fast as it can? Okay, is it producing as many parts as it can? And of those parts, are they all good parts or are they scrap? Okay, if all these things line up and you get 100% score, you're doing well. It's almost always an impossibility. It's a struggle to make it. Dry ice cleaning affects every single one of these things. If the machine is clean and cool, it's going to run fast. If the machine is clean and cool, it's going to make the right parts and it's going to reduce the scrap. Okay. We affect every single one of those. So if you want to achieve that score, you need a cold jet. Here's what you need to set it up. Of course, you need a cold jet. We have plenty of those. Okay. We have what I call inside outside. So inside the plant, you would just simply hook it up to your plant's compressed air system. The People want to think in terms of pressure. What kind of pressure are you using? Well, we're going to use whatever your line pressure is. In most plants, it's about 80 psi. What's more important is the air volume. This thing needs 130 CFM of air, so you're going to have to hook it up to a 3/4 inch or a 1 inch airline. And everybody, why does it use so much air? Well, because you can't take a garden hose and put it into a fire hose and get the same result. Okay. But the next panicky thing is, well, wait a minute, I'm using that much air, that's going to shut our line down. Well, we're not going to pull the trigger and leave it on for an entire hour. It's an intermittent use, so you don't have to worry about shutting the plant. In the 31 years I've been here, in some 10,000 demonstrations, nobody has come running down the hallway going, hey, you're shutting the plant down. Okay, for outside setup, you'll need to go to the tool rental, or maybe we'll have one of your own, and rent a diesel air compressor, okay? You need a 185 CFM rated or up. The more volume air you put behind it, the more performance you're going to get at the nozzle. Now, because the air quality coming off that compressor is hot and wet, because it's just a nature of compressing, you need to treat that air. So that thing in the middle there is what we call an aftercooler. And what the aftercooler does is it takes there's a filter in it, so it takes the excess moisture out of the air. And then there's a radiator fan in there to cool the air down to about room temperature. The reason that's important is if you send hot air right into the cold jet, and now we're putting dry ice pellets in it that are 110 below, you get a dew point reaction at the machine. Now you're making water, and that's just going to create problems. So it's important to have the aftercooler. So air compressor, aftercooler, cold. Well, yeah, what kind of PPE do we need? Okay, ear protection. There is some noise to the machine. It's actually at the nozzle tip. So regular earplugs. Now OSHA wants you to wear plugs and muffs for 8 hours of operation continuously. If you're just going to use it intermittently, plugs are fine. You're going to run it all day, plugs and muffs. Eye protection. Well, we're all wearing safety glasses anyway. And gloves. You need some regular or work gloves. You do not have to buy some crazy welding glove up to here. Everybody thinks if you touch dry ice, your arms are going to fall. That's not necessarily true. So just regular cotton gloves, all you need. And although your arms are not going to fall off, you don't need to be digging around in the dry ice. So you should use a scoop to handle it when you convey it from the storage container to the blasting machine. So ear protection, eye protection, gloves, scoop. Like I said, we have 100 some applications in so many industries. I mean, almost anything. If you're manufacturing something, you've got dirty parts, moving parts, water problems. Gosh, anything. Chewing gum. Sold a machine to a university. All they want to do is clean the chewing gum off the sidewalk because they couldn't use any water. Okay, but the list goes on and on and on. I'm going to save you. Okay. Manual cleaning versus dry ice blasting. And look at this guy on the left who's got to clean this mold so he can get this production line going. That doing this kind of cleaning never gets the mold 100% clean, and it's arduous. It's like flossing a cat. All right, look what's going on the right. It's nice and cool. It's getting every nook and cranny. It's doing a complete job. That guy on the seat on the left there, that is a mold that makes a car seat, and that's wax on there. And when it wears out, you got to scrape it all off. The guy on the right, pulling it off like butter. It takes hours to clean one of those seat molds with traditionally. You do it with cold jet, 20 minutes, 10 minutes. Way back when we clean a lot of molds, okay? Back when I started this thing, that the tire industry was big on this, and the process to clean a tire mold, and the reason you have to clean it is because after you make so many of them, the tire mold gets dirty and it doesn't make a tire. So they have to cool this thing down. It's 380 degrees. It's a big, heavy mold. Even a passenger tire is about 300 pounds. So yeah, you have to unbolt it from the press, and then you bring a crane over and you take it over to this area and you sandblast it, which is a problem because the sand doesn't like the aluminum and it wears the lettering. So that mold only has a certain life. Every couple of years, you've got to replace it, and they're expensive. All right, then they bring it back, they heat it back up, boil it, that whole thing. This takes 13 hours to do this process. I can clean one while it's hot online in about 11 minutes. Okay. Well, this is what it means to the tire maker. The tire maker now makes an extra 3,500 tires per press per year with zero tool wear and no landfill. Well, that is a remarkable deal, but it's the same thing with any molded products. I don't care if you're making Barbie doll heads or dog bowls or cell phones, okay? Or anything on a car. From bumper to bumper, it's all made in a mold or a stamp or a die or a casting. All of them get cleaned. All of them are hard to clean. This makes it easy. The food and beverage industry loves us. Okay, so, you take a soda can, a beer can, something like that. From the beginning, you got to stamp it. The stamp gets cleaned. Has to be decorated and printed. That gets cleaned. You have to put a coating on the inside. That gets cleaned. Then to fill it, there's soda, beer, fruit juices get slopped all over. They get these chains all sticky and the wire harnesses and that threaded thing right there. That gets, and look at that. It's been there for 100 years. Nobody's ever cleaned it. What they clean it just enough to get it passable. With this thing, you can clean everything without messing up the line. I mean, that thing has never been there. Okay. And then when you're cleaning from the food side, there's an enormous amount of water that's brought it. Okay, what that is, that's a nut roaster. Okay, and that thing gets the oils burn onto that plate. That whole thing has to be disassembled, cleaned with caustic soda, reassembled. It takes days. Not only that, the harsh chemicals they use de-season the roaster, so the peanuts taste like Easy Off. They have to throw them all away until it starts to season again. But anyway, in this mixing and stuff, um, uh, an obscene amount of money is water is brought into the plant, to make the ingredients, but 40% of it is used for cleaning. Um, if you can reduce your water consumption, because the world's running out of water, if you can reduce your water consumption and sewage costs and water treatment costs by 40%, by using a byproduct, you really have something there. The other thing is, because there's electricity and moving parts in here, you've got to take it all off to wash it. You can clean things just while they're right online. And that is a big deal. Okay, automotive assembly plants. So, where they're putting together the Cadillacs and Hondas and stuff like this, there's a lot of welding and stamping and painting. Okay. Welding, you may have seen a video of, those lines of robots and their sparks flying. That's welding. And those sparks flying end up back on the weld fixture. That's a weld fixture right there. It holds two pieces of metal, robot welds it. When it gets built up with dirt and spatter, the part doesn't fit in there, and then the electronic sensor won't tell the robot to come down and weld it. That's a bigger one. So guys have to go down there with hammers and chisels and chemicals and hammer and chisel all the stuff off of this thing. This takes an obscene amount of time. And it's also very difficult on this expensive tool and the electronics. All right. Dry ice, you can do it in a matter of minutes. You might recognize that color. That's Caterpillar. Um, that is a downdraft paint booth. So the overspray gets drafted down through the grates in that floor. And then there's a stream of water that collects it and takes it to sludge it out. If you don't clean that thing, the air can't get through and it burns up the fan. So we clean a lot of these. Robots need cleaned. Um, uh, everybody says that the robot replaces people or doesn't call and say, "Well, robots need cleaned," you know. And if you don't clean them, they get hot, they move well, they start to lose their performance. Um, and you know, people coming through your plant want to see a clean plant. Oh, they don't want to buy anything from it. Like this, that's all weld slag, and it's hard as a rock, and that all responds well to thermal shock. Printing. If you've ever seen a big commercial printing press, it might be as big as a football field from one end to the other, and it's tons of moving parts, chains, gears, electronics, and then it gets inundated with ink and glues and carton dust or paper dust that just gets built up. And when it comes time to clean it, you know, there's a team of people that run that press. Well, they got to go get the scrub brushes and the scrapers and some super harsh chemicals and rags, and they start cleaning it. And again, it gets clean enough so it's passable. And all those rags and things end up in the drum and they end up in the landfill. Now, inks respond well to thermal shock. Okay. And what you're watching right here, that is some super thick ink. And that's a good example of the impact and gas explosion because there's a lifting effect. And sometimes the thicker the contaminant, in this case, the ink, the faster it comes off. See what I mean? But again, to the guy that's got to clean this thing, this is the best job in the plant. Contracting cleaning. Okay, there are groups of guys that, you know, they'll come in your plant and clean stuff or maintenance stuff or do whatever you don't really want your own plant people to do. That right there, that was our plant when we remodeled this one. That is a 5-axis CNC machine. That's me again. You'd think they'd have some other footage. In this case, these guys decided to go and clean all their CNC equipment because it's very old and very dirty. And they found that when they did good housekeeping and cleaned their equipment, the morale in the plant got better. Attendance got better. Heaven forbid the guy has to come and run this machine all day and it'd be a filthy mess. Also, you know, everybody gets one of these man fans, especially in a plant that's hot, and they get dirty. And when they get dirty, they get off kilter and they're out of balance and they're hard to clean. You can clean them while they're right online. This is fire soot. They had a fire in this building. Okay. If you don't clean it, the whole building stinks like fire for the rest of your life. So oftentimes they have to rebuild, but you can cold jet all that fire soot right off. This guy is cleaning his Ferrari. You know, for the detail shop that's going to do this, this is awesome because, again, cleaning a Ferrari by hand or any car is like flossing a cat. It's a long day of arduous work. If you can make short work out of it, the detailer can do so many more of them in a day's time than he could normally do. And again, the applications go on and on. The contract cleaner. Okay, I'm going to come back to this. Okay, so metaphorically, after seeing what we're doing, we have big applications and we have little applications. These machines do the big applications, and the tabletop things do the smaller applications. That ultra machine will do both. You can hook up the big air cleaning, and you can put attachments on it to do small air cleaning. Jokingly, we call it the weed whacker and the mower. But also, you know, if you've done any research, and I'm sure you have, you'll see that we are not the only ones that build these. We are the only ones that have been building them for 40 years. We're the only ones that have an R&D budget. We're the only people that make a profit at it. Okay. And we're not the low cost version of this thing. You can go right on Amazon and buy something for $3,000 that looks just like this. But what makes these expensive is that dry ice pellets don't flow very well. If they flowed well, you could put it into a sand pot. All right. It has to have a sophisticated feed mechanism. You have to have feeder parts that that respond, don't over respond to going from room temperature to 109 below zero. Then you have to have hoses and applicators that remain limber at 110 below. There's a lot more to it than you think. The people that are selling $10,000 machines and $15,000 machines have been doing this for about a year or two. They probably won't last in this environment because they're building basically something that we designed 30 years ago. And that's all I'm going to say about that. Just be careful. You wouldn't start a tree trimming business with a 12-inch electric chainsaw, nor would you buy on your behalf of your company a piece of machinery that's going to fail, needs parts, has problems, you can't get parts. You're just going to end up with a $10 or $15,000 black eye. Okay, what have we learned? Dry ice has hundreds of applications in 52 industries. Dry ice is safe and easy to use. Dry ice saves time and money. Time and money makes money. Okay, and that's where the rubber meets the road. Dry ice is easy to get. You can get it just about anywhere. Learning how to use the machine takes about 10 minutes. And if you forget or get a new employee, we've put a QR code on the machine, and you can take a picture with your phone and watch an entire training video, as well as read the manual from cover to cover. Dry ice is environmentally friendly because it's a recycled byproduct. And PPE is standard and easy to use.